Okay, guys, so we're gonna go ahead and get started. It looks like my camera's actually, there's like a dark spot or something on it, but it looks like it's kind of working today. So hopefully we'll be good. All right, so we're gonna finish up chapter 9 and then we'll start chapter 10. Let's see, so we left off like, I don't know, let's see, slide 30, see where that is. A little bit after that. Okay, so we're going to be looking at the shoulder joint. So we're going to be looking at the shoulder joint. If you remember, right, when I talked about how we named joints, we named them based on the two bones that touch each other. Okay, now you have this structure on your scapula. And if you remember, your scapula is going to be your shoulder blades, right? So your shoulder blades, scapula, there's a structure on your scapula called your glenoid fossa. Okay. So your shoulder joint is also called the glenohumeral joint. All right, so glenoid fossa and the head of the humerus. Glenohumeral. Okay. Out of all of the joints, it has the greatest range of motion. So that's going to be true. Okay, so for that true false question there. The reason for this is if you look at the glenoid fossa, so you have two ball and socket joints in your body, right? The ball and socket joint in general has the widest range of motion. Okay, the two ball and socket joints, one of them is your shoulder. What's the other one? What's the other ball and socket joint? Hip. Exactly. Okay. So your hip. Now the difference between your shoulder and your hip. Okay. If you look at the glenoid fossa on your shoulder, there we go. Okay, so this is going to be your scapula here. This shallow depression, that is your glenoid fossa. Okay. Now, if you look at your hip, on the other hand, it has a much deeper socket. Okay, so let me just fade this really quickly. And you can see here, right, where the head of the femur fits into, it's much deeper than the shoulder up here. Okay. So that shoulder has a really shallow, like, pocket. So it's good in the sense that it gives you the greatest range of motion. However, it is also the most likely joint to dislocate. So most likely joint to dislocate. That's not the highlight. Most likely joint to dislocate. Okay. So shoulder joint, also called the glenohumeral joint. Head of the humerus fits into the glenoid fossa. Okay. True, has the greatest range of motion of any joint. Okay. It is also the most likely joint to dislocate. Okay. And it is a ball and socket joint. Now, for the muscles that go around your shoulder joint, okay, the whole group of them is called your rotator cuff. So, for labeling, for bones, I'm going to put bones in blue. Okay. You have your clavicle, which is going to make up your collarbone. Okay. Clavicle, collarbone. Then you have your scapula, which is your shoulder blade. Okay. Now, it's important to note we are looking from a posterior view on this one and then an anterior view on this one. Okay. Because that's going to help us when we start to learn the names of the muscles. So okay. If you look at the structure of the scapula, okay, so we're looking at our skeleton from the back here, right? So if you look at the structure of the scapula, you have this thing on here called a spine. Okay. The reason why I point this out is because we have a muscle above the spine and muscles below the spine called supraspinatus and infraspinatus. Okay. The other reason I point this out, all right, when you're looking from an anterior view, so you're looking from the front, okay, you can see here that that surface of the scapula is going to be flat, right? Because that's going to allow it to slide over the ribs. All right. Now, we have a couple of different important muscles. Okay. So they're called your sits muscles. You have supraspinatus, infraspinatus, teres, there's two of them, and then subscapularis. Okay. So if we look at them, supraspinatus is going to be above that spine. Supra meaning above, spinatus, spine. Infraspinatus, infra below, spinatus, spine. Okay. Then you have your teres minor and teres major. And underneath you have subscapularis. Okay, so if you remember that flat surface I just showed you, that is where your subscapularis muscle is located. It's located under that spine, that scapula on that flat surface. Okay. Oh, and your humerus. I forgot to highlight the humerus to label. Okay, but your humerus is going to be your upper arm. Now, we probably won't point to like the teres minor or the teres major and be like, what muscle is this, right? We might ask you something like the supraspinatus, infraspinatus, subscapularis, etc. are part of which group of muscles? Something like that. Or which group of muscles supports the shoulder? Okay, so we might ask you something like that. Have class and oh, I see. Okay. I'm just going to send out a thingy. Hold on. Okay. Do the same thing with my DFA class. All right. Yeah, sorry, I wasn't talking. I was sending out a message because Brianna noted that like a lot of people are in funds, which makes sense because normally when we're online, you guys have funds first and then me. So I just was sending out an email to you guys. Okay, so next we're going to talk about your elbow joint. Now your elbow joint has two articulations, okay? You have your humerus and your ulna, and your humerus with the head of your radius. Right, so this is the diagram from your book that shows all your ligaments and whatnot, but it doesn't really show you where the bones touch, right? So that's why I have this picture here. Okay, so you have your humerus, okay, your ulna, and your radius. So you see how the humerus is touching both the ulna and the radius, right? And then you have a whole bunch of ligaments to stabilize the joint. What type of joint is it? It's a hinge joint. Exactly. Wait, did I say that? Anatomy was. I think I said that anatomy was the right time. Now I'm nervous. Hold on. Yes. Okay. DFB 9 to 11:30. Okay. I don't know why they made the schedule like this, where they have you guys in at like 9 and then 11:30 on Thursdays. It's weird to me. But. Okay. So as far as labeling goes, you can just label humerus, ulna, radius. Sorry, I realized my pointer wasn't on. Humerus, ulna, radius. Okay. Your ulna has this like loopy guy here. The radius is like a thin top to it. And then the humerus is the one that makes up the upper arm. Next, we're going to talk about our radial-ulnar joint. Now, whereas the radius and the ulna both articulate with their humerus to form your elbow, the radius and the ulna also have their own joint between them. Okay? What it basically does, like a stick or something. Yeah, no. Okay, so the way that the radial ulnar joint works, all right, the radial ulnar joint is going to be a pivot joint. Okay. And the radial ulnar joint, let me make sure because I added this from last semester's packet and I only have my last semester's packet in front of me. Make sure that I have all the fill in the blanks for you guys. Sorry, I'm thrown off by teaching online on Monday, I guess. All right. There we go. Yeah. So the radial ulnar joint is going to be a pivot joint. Okay. It is a articulation between your radius and your ulna, hence radial ulnar. All right, and the way that it works, it is like just below where you see that elbow joint being, okay? And what happens is you have these ligaments that basically wrap around from your your ulna around the top of your radius, okay? So they loop around like this, and then the head of the radius goes in here. And that allows it to turn like this, okay? Now, because the head of your radius is really small in kids, all right, and adults, you can see there's a bit more of an exaggerated like gap to it almost. In kids, they don't have that. So there's something called nursemaid's elbow, where it can just slip out through that ligament, pop out like that, okay? That's one of the reasons why you don't want to pull on kids' wrists. It's called nursemaid's elbow because you get frustrated and you pull on the kid's wrist, right? So it can partially dislocate the radius really easily in children. All right. So radial ulnar joint, pivot joint, articulation between the radius and the ulna. Common condition that happens here, nursemaid's elbow, because the head of the radius is really small. Next, looking at your knee. Now for your knee, do not worry about a whole lot of these ligaments, okay? So let me make sure we took out most of these. Yeah. So you don't need to know all of these ligaments, but there are a lot of ligaments in your knee. Actually, I think I left in the word meniscus, but like you guys don't need to be able to identify lateral versus medial menisci. Okay. Now your knee is going to be an articulation between your femur and your tibia. All right. And then you have your patella kind of like covering the front here. And so this is going to be my beautiful patella. And if you remember, the tibia is going to be the thing that bears the most weight of the body, right? So the big T-shaped bone here, that is your tibia. Okay. It is the largest and the most complex joint. Like I said, there's a ton of different ligaments in here. You have these very specific things called meniscuses or menisci, okay? So I can delete this so you can see. But you can see the menisci are these little like cushions here, okay? So they're going to act as shock absorbers. Blah. All right. And again, you also have your fibula, but your fibula does not bear any weight, right? So the fibula is going to be that emotional support bone for your leg. It doesn't bear weight. It's just there to help out the ankle. Okay. So for labeling, you have your femur, you have your patella, which like it does actually have the patella on your diagram. Fibula, tibia, and then you can just point to the meniscuses. You don't need to know medial versus lateral. Okay. So you can just add in meniscuses. That's what those like purple things I highlighted were. And what type of joint is it? It's a hinge joint. Okay. I think that's everything for the knee. Yep. Okay. Next, taking a look at your hip. Okay. Again, this diagram just shows you the hip with like a whole bunch of ligaments in the way, right? It doesn't show you the nice socket. So that's why I have the diagram I do. Okay. Your hip is going to be the other ball and socket joint in your body. Right? So what type of joint? It's ball and socket joint. But It is more stable than the shoulder joint because the hip socket is deeper than your shoulder. Okay. And it's an articulation between the femur and what's called your acetabulum of your pelvis. Okay. So the acetabulum is going to be this cup guy here. Okay. So this cup here is going to be your acetabulum, right? So this whole thing is your pelvis. Your acetabulum specifically is like this thing, okay? The little pocket. Okay. Now, the nice thing about the hip that the shoulder doesn't necessarily have, okay? Spinning. What are they called? This thing. Okay. Is there like a video somebody? Yes, there is. Okay. So if you like these fidget spinners where you like twist them and the ropes like twist around each other and it brings it up. Let's see.
Check out this simple and stunning affordable toy wand. No LED lights necessary here. When a fidget toy...
Okay. Now, the reason why I show you this is because like when you spin that, right? The ribbons are going to like twist around each other and bring that base up. Okay. That's kind of what happens in your knee. Those ligaments, when they twist around each other, okay, so when you stand up, they're going to twist. All right. And they're going to pull that head of the femur deeper into that acetabulum and make it more secure. Okay. So you can see here how they're like twisting. When they twist and pull it further in, it makes it more secure. Okay, like 10 more sections. Yeah, so the rotator cuff muscles are going to attach to your glenohumeral joint, right? The glenohumeral joint is another name for your shoulder. Okay, so this is kind of how we'll ask a question about the rotator cuff muscles. Stuff like that. Okay, like 10 more seconds. Yeah, so your elbow is going to be a hinge joint. Okay. Now your elbow, right? Not your radial ulnar joint. Your radial ulnar joint is specifically like between your radius and your ulna. Your humerus is not involved in your radial ulnar joint. Next, we're going to talk about a couple of different types of arthritis. Okay. So, starting with rheumatoid arthritis. For describe, you can just put inflammation of the joints from an autoimmune disorder, something like that. Okay. So, rheumatoid arthritis, abbreviated RA, inflammation okay. Inflammation of the joints due to autoimmune. Oh, I realized I didn't send that to the whole class. Hold on. Okay. So, inflammation of the joints due to an autoimmune disorder. All right. Basically, in an autoimmune disorder, right? Auto means self. Immune system. Basically, what happens is your immune system attacks your own body tissues. Okay. Specifically in rheumatoid arthritis, it is attacking the tissue in your joints. Okay. So your articular cartilage, your joint capsule, your ligaments, stuff like that. Okay. And what happens is it causes that swelling, you see, that eventually can cause the bones to erode and your joints to be deformed. So if you look like how the fingers are all a little like lumpy. Okay. So autoimmune disorder attacks its own tissues. All right. For osteoarthritis, on the other hand, we already know osteo means bone, right? So we're halfway there. So osteoarthritis is from wear and tear damage. Okay, so what happens is in osteoarthritis, over time, the bones are rubbing against each other over and over and over again. Okay, it's like starting a fire, right? And it causes the ends of those bones to degrade. Right, so osteoarthritis is wear and tear damage. Rheumatoid arthritis, autoimmune disease. Okay. So for osteoarthritis, it gets abbreviated OA. Okay. Now these can happen, I believe, in any joint, but they're gonna happen a lot of the time in like your interphalangeal joints, your knees, it's places that you're like constantly moving, right? Like your elbow, stuff like that. Okay. So osteoarthritis, wear and tear, rheumatoid arthritis, autoimmune, meaning that your immune system is the thing causing it. Okay, let's do like 10 more seconds. Yeah, so away from the midline, abduction. When you abduct something, you take it away, right? Abduction. Adduction, you're adding, right? Add to the midline. Okay, let's do like 10 more seconds. Yeah, so palms face down, pronation. Okay, palms face up, supination.
Did you say supination or pronation?
The correct answer was palms down, pronation. If it's palms up, it's supination because you make like the soup bowls.
Okay.
Okay. Most likely joint to be dislocated is going to be your shoulder, right? It's because it has that shallow pocket. Okay. Elbow or knee isn't super prone to dislocation. Palms up. Okay. So next we're gonna do chapter 10. Let me get it uploaded. And then to download your chapter 10 packet, Thank you. I love my memes. Go to week 6 materials, pre-class work. Okay. So I'll give you guys a second to do that. And while this is uploading, and I'm just gonna grab something to drink really quickly. I will be right back. Okay. And I'll still print out chapter 10 for you guys. I don't know where to like leave it for you guys so that you can grab it. I'll leave it like in the classroom on that windowsill. Like off to the side there. You guys can just grab it like between classes. Because I'm going to campus later tonight, so I'll print it out for you guys and you can grab it. That way you still have it for like labeling on Thursday. Okay. Let me pull it up, make sure that I'm following along because there's a lot of changes from last semester. So for which muscles to focus on, there's a list of like relevant muscles to know. Okay. The other thing I have for you guys is, and I'm going to print this out and give it to you as well. Where's my, let's try this tab instead. Okay. There's a list. Should be the same one. Okay. So if you guys want to have this so that you have like a little bit of information on each one next to the list of muscles, you have that. Okay. But the front of your packet has like the explicit list of muscles to know. Okay. There's also 2 like landmarks I want you guys to know: your Achilles tendon and your linea alba, and we'll talk about those in a minute. Okay. So you have 7 main functions of muscle. Okay. We have movement. So like I use that rope and plank analogy, right? Where you pull on the rope. Let me pull it up on my iPad so that I have this following. Like I said, there's a lot of changes from last semester. We took a lot of stuff out. I want to make sure that I don't like focus on irrelevant things. Okay. So movement, when that like you tie the rope to the plank analogy and then you pull on it, the rope is going to be the muscle, right? That's the thing actually pulling on the stuff, right? Maintenance of posture and body position, right? So it's going to help you stand upright. It's going to keep your body in place. Respiration, we're going to talk about the main muscles for respiration. But it's not that your lungs have muscles inside them. It's that the muscles around your lungs allow your lungs to breathe. Communication, just like in line with respiration, okay? It's pushing the air out of your lungs. It's responsible for the speaking. It's also responsible for nonverbal communication, like facial expressions or like hand gestures, okay? Constriction of organs and blood vessels. So it keeps everything in place. Pumping blood. Excuse me. So pumping blood, right? Your heart is just one big muscle. So yes, your heart is one specific muscle. Like, well, it's an organ, but it's made mostly of muscle, right? And then heat production. As you're using your muscles, okay, you're running around, you're producing heat as a byproduct of all of those metabolic processes that are going on. Muscle. Okay. Now there's a couple key characteristics of muscle we want you guys to be familiar with. Okay. The first one is going to be excitability, which makes sense, right? It's the ability to respond to a stimulus. So either a motor neuron or a hormone. You can think about it as like, I don't know, you get tickets to a concert or something, right? You're excited. Something happens and you get excited about it, right? Excitability, ability to respond. Contractility, the ability to shorten. Okay, so when you contract something, it shortens it. These are the two that people get confused a lot of the time. Extensibility versus elasticity. Okay. Now, extensibility is stretching. Okay, so extending. When you extend something, you stretch it, right? Elasticity, on the other hand, is the ability to go back to its original length, right? So the example I always use, if I hit this desk, right? If I hit my table, okay, my table goes right back to its original shape. So this is actually going to have high elasticity, right? So if I hit the table stays the same shape unless I hit it so hard that it breaks. But elasticity is that ability to go back to its original length. Extensibility, on the other hand, extensibility is the ability to stretch. Okay. Elasticity, another example, Play-Doh. If I punch a ball of Play-Doh, right? That ball of Play-Doh is not going to snap right back into its original shape. It's going to stick with the new shape. Okay. So a ball of Play-Doh has low elasticity. So excitability, ability to get excited. Contractility, ability to shorten. Extensibility, ability to stretch. And elasticity, the ability for the muscles to go back to its original length. Okay. So 4 characteristics of muscle. Now, for overview of types of muscles, striated means striped. We're going to talk about that again in a second. And I also have this whole table typed out for you guys, so I'll leave it up, and then that's when we'll go on break so that I can just leave it up for you guys. Okay. So we have 3 types of muscles. You have smooth muscle tissue, cardiac muscle tissue, and skeletal muscle tissue. Okay. Find them in different locations. They do slightly different things. Starting with smooth muscle. Smooth muscle is going to be involuntary, all right? Meaning that you do not consciously control it. You're going to find smooth muscle in areas like your digestive tract, your blood vessels, your bladder, your airways, and your uterus, okay? Now, smooth muscle is considered non-striated, meaning it is not striped. Okay, so striated means striped. Type that up in the corner here. Okay. So striated means striped. Smooth muscle is non-striated, meaning it is not striped. Okay. It also has this thing called a spindle shape to it. Okay. So what I mean when I say spindle shaped, it goes like this. Okay. So it has tips that are thinner than the belly of the muscle cell. Okay. It's going to be regulated by a couple different things, including chemicals, hormones, and stretch. So when your stomach fills up, you have a stretch reflex that causes your stomach to contract afterwards. Okay, so if you fill up with food, your stomach's like, oh, we better start like kicking off those digestive processes, right? So that smooth muscle is going to respond to the stretch that happens when your stomach gets filled up. Okay. Next, we have skeletal muscle, and this is what we focus on from the muscular system after we talk about the 3 types of muscle cells. Okay. Skeletal muscle is what causes the movement of the body. It looks very, very striped when looked underneath a microscope, when examined under a microscope. Okay. So super striped. It is known as voluntary because it can be contracted at will. Striated. Voluntary, found where? Found all over the body. Okay. Appearance, long and thin and bundled together. Each one of these is a muscle cell. Okay, they're all like stacked together. Okay. Other notable features, innervated by the somatic nervous system. Okay. And like I said, this is all typed out on the table. So whatever you haven't gotten down yet, don't worry. Oh no, did the cardiac muscle one accidentally got deleted. Okay. Cardiac muscle is also going to be involuntary. Okay. You're going to find it in your heart. So cardiac, heart. Cardiac muscle cells are also striated. Let me pull up my last semester's PowerPoint. I didn't realize that it got deleted. Hold on. Oh, it got deleted from this one too. It's so weird. Okay. So cardiac muscles only found in the heart. All right. None of my previous PowerPoints have it on here for some reason. It is also going to be striated. It has what's called a branched appearance. Okay, so whereas the skeletal muscles are like long and spindly, you can see cardiac muscle has more of like stretchy. I don't know. It does like it looks like they kind of like wave over one another like this. This is good. Okay, so branched appearance. It's not just like one on top of another. Like you're not grouping straws together. And they kind of merge in and out. Okay. So that's going to be the appearance. Other notable features. It has this thing called intercalated discs in there. This kind of shows them pretty well. They're basically just like buttons that stick the muscle cells together better. Okay, so anytime you hear someone saying intercalated discs, they're talking about cardiac muscles. Okay, so you can see them really well in this diagram here, too. Okay, so you see that branched appearance and you see these intercalated discs stitching those together. Okay. So I'll leave this up for you guys. Yeah, I know it's a little early, but I want to leave this up for a little bit so that you guys can type it or like write it out. I'll just leave it up for a minute or two and then we'll go on break. So, or we'll go on, yeah, we'll go on break now so that I can leave this up for 10 minutes. Okay. So I will see you guys in 10 minutes. Set the timer up. All right. I'll see you guys in 10 minutes. Okay, so let's get back into it. So next, talking about muscle attachments, right? Muscles are going to attach to bones in two different ways. Okay, you can either have, oh no, come on, man. What is this? Hold on 1 second. Let's do like an extra like 3 minutes on break so that I can find this slide that got deleted. Um, so okay, hold on 1 second. Sorry about this, guys. Okay, I fixed the slide. I'm just waiting for the PowerPoint to upload. So, you know what? I can just share screen like this. Yeah. This is nice. Okay. So, a skeletal muscle cell is also going to be called a muscle fiber. Okay. And so, anytime you hear muscle fiber, same thing as skeletal muscle cell. Right. make sure that I'm getting all of them. Yeah. Do not worry about a bunch of these in-between steps here, okay? So you have muscle fibers surrounded by endomysium, which is grouped into a fascicle, which is surrounded by perimysium, which is then grouped into Don't worry about that, okay? I want you to know muscle fiber, and I want you to know that surrounding the muscle itself, you have an epimysium. Okay, so epi meaning outer, mysium, that connective tissue, okay? So a whole bunch of muscle cells get bundled together to form a muscle itself, okay? And that muscle is going to be surrounded by that epimysium. And then surrounding that epimysium, you have what's called fascia, okay? Let me get, is it uploaded now? Yes, it is. Awesome. It's way further ahead than I meant to do. Okay. So, skeletal muscle cell is also called a muscle fiber. Okay. Muscle fibers get bundled together, which get bundled together to form the muscle itself. Right. And that muscle is going to be surrounded by what's called the epimysium. So if you remember, epi means outer. Okay. Epimysium is that outer covering. Then you have connective tissue called fascia, which surrounds that. Okay. You have two types. You have deep fascia, which is going to be between muscles, and then you have superficial fascia, which is just under the skin. You've already learned about superficial fascia. It's also called your hypodermis. So hypodermis, under the skin. Okay. Now, muscles can attach to bones in two different ways. Okay. You can either have a direct attachment where the muscle fibers merge with the periosteum. And if you remember, that periosteum is on the outer covering of the bone, right? So direct attachment, those muscle fibers merge with the periosteum. Okay. Indirect attachment, it can attach to another muscle first, or it can attach to the bone through a tendon. Okay, so an indirect attachment, it is not going directly from muscle to bone. Okay. If it is going past another muscle, okay, it can extend past as a broad flat tendon called an aponeurosis. Okay. A good example of an aponeurosis, you can see it on let's see. Dorsi usually has a pretty big one. Let me just get my muscular system back up. Put some muscles on this guy here. Okay. So you have your latissimus dorsi here, right? He has a nice big broad flat tendon right here. Okay. Another good example, usually found at the back of the calves here. Oh yeah, this guy doesn't show very well. But there's like aponeuroses up here as well. Where's another really good one? Here we go. Up here at the top of your skull. This is all tendon. This is another like aponeurosis up here. Big, broad, flat tendon. Okay. Now, aponeuroses are then going to fuse with the covering of another muscle, which then attaches to the bone in some way. Okay. Now, you can also have an indirect attachment to a bone, right? Where what happens is the epimysium extends and becomes a tendon, which then merges with the periosteum. Okay, so this is different than direct attachment because direct attachment, the muscle cells themselves are merging with the periosteum. In indirect attachment, you have that intermediate step. You have a tendon in between the two. Okay. Now, tendons and aponeuroses do not break very often. They are very, very, very strong, but they can get pulled away from a muscle. So when you like sprain something or you irritate something, or if you get like shin splints or stuff like that, yeah. So a really good example of the difference between aponeurosis and Achilles tendon, if you look at the back of the thigh, or the back of the calf, sorry. The app that I used didn't show it very well, but at the top of your gastrocnemius, which is the calf muscle, you have aponeuroses, so those flat tendons. And at the bottom of them, you have your Achilles tendon. Now, for contraction of a muscle, okay, there's a couple of different terms that you guys should know. Starting with motor unit, okay? Think of it as like a, I don't know, military unit or whatever, right? A motor unit is going to be a neuron in all of the fibers that it stimulates. So a neuron is a nerve cell, all of the muscle cells that it stimulates, okay? So you have your commander and then everybody that it falls under their command, right? Then you have threshold. We're going to talk about threshold again when we get to the nervous system. Okay, threshold is the minimum voltage needed to cause a muscle contraction. Okay. So in order to actually cause that muscle to contract, right, you need to reach a certain voltage. Otherwise, it just doesn't do it. Okay, it doesn't, because there's very transient electrical changes going on in your body at any given time. Okay. So by having a set threshold saying, in order for me to contract, you need to reach this level. Okay. That permits you to like not constantly have your muscles contracting in response to just like things that are normal for the body to be doing at any given time. Okay. Then you have twitch, which is a single brief contraction, right? So when something twitches, right? That's a twitch. Single brief contraction. Now, when you have these impulses coming on top of one another, okay, what happens is the last contraction ends up being stronger than the first. Okay, so you get this like stacking. All right. So you have twitch after twitch after twitch after twitch. Okay. And they start to build on one another. Now, in tetanus, okay, what happens is these impulses are arriving so quickly together that you don't have a chance to fully relax in between them. You still have some relaxing. So if you see here, right, this is supposed to represent contracting because you have an increase in tension, right? So you see contraction, you see relaxation, but it's happening so quickly that it doesn't have a chance to go all the way back down to the bottom here. Okay, so this is called incomplete tetanus. So you can see it gets stronger and stronger, but it doesn't get to relax all the way. So it's incomplete tetanus. Now, on the other hand, if you have these stimuli happening so quickly, one after another, okay, that they end up merging into like one prolonged contraction, this is complete tetanus, okay? You don't have any sort of relaxation. What ends up happening is eventually your muscles get fatigued. They just give up. Okay. You cannot contract indefinitely. At some point, your muscles give in and they let go. So, complete tetanus, they do not relax at all. In incomplete tetanus, there is partial relaxation. Okay. Okay, let's do like 10 more seconds. Yeah, so a condition of rapid contraction with only partial relaxation, incomplete tetanus. You're still seeing some relaxation, just not a lot, right? So rapid contraction with partial relaxation, incomplete tetanus. Incomplete tetanus, so complete tetanus, the muscles do not relax at all. Eventually they just give out in fatigue, okay? A twitch is just a single brief contraction. Don't worry about trepe, we didn't cover that this semester. Okay, now skeletal muscles are gonna work in groups to create movement. All right, you have your main muscle triggering the movement called your prime mover. Then you have muscles that help out with this. Okay, synergists are going to help the prime mover. All right. And the muscles that are balancing these movements are called antagonists. So if you like know literary stuff, right? The antagonist is the villain. They are the one that is opposing the protagonist. Okay. So the antagonist, okay? Antagonist. They are the ones that oppose the movement. Okay. Now, the reason why muscles are going to work in groups like this, all right, you cannot have both your antagonists and your prime movers contracting at once. So if you think about how your elbow works, right? You're contracting up here, you're contracting back here. If you're pulling on both of these at the same time, it's going to cause one of your muscles to rip because it's going to like, the tension can't be increasing on both sides indefinitely. It's bad, right? When you contract your elbow, when you flex your elbow, okay, you're contracting these muscles up here. And at the same time, these muscles down here need to be able to lengthen, okay? So you contract your elbow, these muscles up here are going to be shortening. Well, these guys down here are going to stretch out. Okay, so these are going to be your antagonists. When your prime mover contracts, your antagonists are going to relax. Okay. So prime mover, the muscle triggering the movement. The muscles that assist with this, synergists. Okay. The muscles balancing these movements, antagonists. So the antagonists are going to oppose the prime mover. When the prime mover contracts, the antagonists relax. Okay, this always seems to be a point of confusion every semester, so I'm going to type it out. Triggers the movement. Balance. Okay. So prime movers trigger the movement. Synergists are going to assist. Antagonists are going to balance. So when the prime mover contracts, the antagonist will relax. Okay. So for muscles, there is a lot of labeling in this. Okay. So you'll feel the packet when we print it out. It's not as long as it was last semester, but it's still pretty hefty. Okay. You want to be able, they think this exam is like the only exam that we include pictures on. Okay. And it's not like the entire exam is pictures. I'm talking like we put like maybe 4 or 5 pictures on the exam, okay, of either muscles or bones. However, you want to be able to like identify which muscle we're describing. So learning these by using the flashcards and whatnot is going to help you. Okay, because even if we don't put like the frontalis muscle as like one of the muscles that we put the picture up of, we could say which muscle can be found on your forehead and raises your eyebrows. Or we could say which muscle is responsible for opening and closing the mouth, talking about your orbicularis or oculi, or sorry, orbicularis oris. Okay, so knowing the muscles of the head and the neck. We're hoping to have the exam packet done by the end of this week. Dr. A and I are working on it, so I'm hoping to have that done by the end of this week. So that way you guys have it for like 2 weeks. But yeah. Yeah. So if you remember frontal region, right? Frontal region is going to be your forehead region. Okay. Your frontalis muscle is found on your frontal region. Okay. The way that I always explain muscle movements, if you look at like the stripes of your frontalis muscle, they go like this, right? Just take your fingers, put them on either end, and make the distance between your fingers smaller. Okay. So your frontalis muscle is going to raise your eyebrows. Orbicularis oculi. Okay. Orbicularis is going to be a round muscle. So orbicularis, orbital, oculi, eyes. Okay. You have another orbicularis muscle, orbicularis oris. Just like oculi means eye, oris means mouth. Okay. You have an orbicularis oris muscle that runs around your mouth. Orbicularis oculi is going to be responsible for closing the eyes when blinking or squinting. Orbicularis oris is going to close the mouth and purse the lips. Right? Zygomaticus. So zygomaticus muscles are found like here on your cheeks. Right? The whole point of the zygomaticus muscle is to pull the corners of your mouth upwards when you're smiling. So you check these in facial symmetry checks. All of the muscles that we chose have some sort of clinical relevance to you guys. So all of that's like listed on here, as well as like that little like handout thingy that I'll print out for you guys. Okay. So orbicularis oris closes the mouth and purses the lips. Zygomaticus draws the mouth upwards when smiling. So facial symmetry checks. Okay. Orbicularis oris closes the mouth, purses the lips. Orbicularis oculi closes the eye when blinking or squinting. Where's the next one? Buccinators. So your buccinator muscles are like, if you look here, right, they're right underneath your masseter muscle. We'll talk about the masseter muscle in a second. But buccinator muscle, the way that you can remember buccinator, first of all, buccal region is your cheek region. Buccinator sounds kind of like bugle. I don't know, bugle's like that horn. So it's the muscle that you use when you're playing the trumpet. Then you have 2 muscles of chewing. Okay, you have your temporalis muscle and your masseter muscle. The temporalis muscle is kind of hard to see from this picture why it's a chewing muscle. Okay. So if you look at it on the 3D guy here. Okay. Your temporalis muscle is actually going to wrap to the inside of your jaw, and it's going to pull it closed that way. So you can see here, okay? You can see the temporalis muscle is anchoring down here onto the inside of the jaw, right? And it comes up and through this archway here. Okay. So your temporalis muscle actually wraps the inside of your jaw and allows it to close. Okay. The next one is going to be your masseter muscle. All right. Your masseter muscle has to do with mastication. Okay, so the masseter muscle is going to be responsible for closing the jaw. All right. So masseter muscle wraps around to the base of the jaw, helps close it. Next, you have muscles that move your head. Okay. First, you have your sternocleidoid mastoid. Your sternocleidoid mastoid goes from here down to here. Okay. So you can break the word down. Okay. Sternum. Cleido, it's talking about your clavicle. Okay, so sternocleido touches your sternum and your clavicle, so your collarbone and your breastbone. Mastoid, it attaches up to this mastoid process up here that you guys don't need to know the name of, but if it helps you remember where to find the muscle, great. Okay, so sternocleidoid mastoid. All right, so it's going to go from like right behind your ear down to that like notch up here. Okay, and again, if you're using your fingers to try and figure out where muscle movements go, okay, here to here. And what happens is when you contract it, right? If I'm just contracting one side, I'm rotating my head to the side. Okay. Now, if I have both contracting, what happens is you pull your head forward. Okay. So sternocleidoid mastoid, it's going to flex the head. It's called your praying muscle. So it can either rotate your head side to side or it can pull your head straight forward, depending on if you're contracting one side or you're contracting both of them simultaneously. It's an important muscle because it's an accessory breathing muscle. So like when you're trying to like extra inhale, it helps pull on that. It's visible in distress. It's also a pretty big landmark for neck exams. So when they start to look for like certain lymph nodes and stuff like that. Okay. Next, you have your trapezius. Your trapezius you can't really see super well on this diagram, but it does make up like your upper shoulders. Okay. So your trapezius muscle is shaped like, okay. But it's this whole guy back here. Okay. So this is all one trapezius. Again, your trapezius is going to be responsible for some accessory breathing. It's going to be important when you're talking about respiratory distress. It's also important in stroke assessments. But mainly it's responsible for lifting your shoulders. But if you're like having shoulder weakness, for stroke assessments. But yeah. Yeah. So trapezius here lifts your shoulders. Okay. When we talk about cranial nerves in chapter 11, one of them very specifically innervates the trapezius muscle. Okay. But your trapezius lifts your shoulders. Okay. Next, we're going to talk about muscles of the trunk. These are going to be important in respiration. Okay. One second. So, external and internal intercostals. Okay. So even if we just break the words down, okay. Costal, meaning ribs, inter, between. Okay, so we're looking at the muscles in between the ribs. All right. External, it's going to be external. Internal is going to be more deep, right? Now, the way that I like to explain that the way that these muscles work in external intercostal muscles, I always imagine it like a giant hoop skirt. Okay, so if I take a string and I tie it to the bottom of this hoop skirt, okay, and I'll pull up on the string, right? Okay, that hoop skirt is going to elevate, right? It's going to pull those ribs up. It's the same thing with your external intercostals. Okay, when they contract, they're going to pull your ribs upwards. All right, so that'll elevate the ribs during inspiration. It's particularly important in asthma and COPD. Internal intercostals, on the other hand, these ones are going to do the exact opposite. So they're going to pull the ribs down. All right. It's more relevant in labored breathing, but it's forced exhalation specifically. When we get to chapter 18, we'll talk about why we say forced expiration as opposed to just expiration. Okay, but your internal intercostals specifically are involved in forced exhalation. Okay, they're really important in labored breathing. Next, we have our diaphragm. Our diaphragm is the main muscle of breathing. Okay, really, really, really important muscle. Okay, you will probably see a question on your exam on this muscle some way, shape, or form. I think we've included a question on the exam, either this exam or the next one, on the diaphragm every semester. Okay, I haven't written the exam yet, so I don't know about this semester, but I'm sure that the diaphragm will come up somewhere, either this exam or the next one, because we talk about respiration in the next one. Okay, the diaphragm is super, super important. All right, what happens with the diaphragm, because it's this big dome shape, all right, when you contract it, I feel like the thick ones are better. Okay, when you contract that diaphragm, you're going to pull it down like this. Okay, and that causes, when your external intercostals are pulling the ribs up, okay, it makes this whole space bigger for your lungs so that you're able to breathe. Okay. This is just like a little video to show you guys like how the muscles move. I think it's helpful. So we'll see. Okay. So don't worry too much about knowing inspiration is active, expiration is passive yet. When we get there, we'll get there. But that just kind of gives you like a nice, like it puts it all together. How, I don't know, like how the muscles are moving around. Okay. Now for muscles of the trunk, okay. You have a couple of different muscle structures in the trunk, right? You have your rectus abdominis, okay? And then we have other abdominal muscles that we like. We don't expect you guys to like know individually, just know that they're abdominal muscles and that they're names, okay? The rectus abdominis is important for like a couple different reasons, like posture, coughing. It's important in abdominal checks. It's important when it comes to pregnancy. It's important for a whole bunch of things. So that's why we have this included in here. Okay. But rectus abdominis is going to flex the lumbar region. Right. So this is like what you're contracting when you see like, or when you do a sit up. Okay. So it causes that forward bending of the waist. Rectus meaning straight, abdominis meaning abdominal. Okay. So you can just, for that fill in the blank, I only have you guys labeling rectus abdominis and the linea alba. The rest of these, your external oblique, internal oblique, transverse abdominis, important in other things. We're not going to ask you guys to identify them though. Okay. Now, in between your two rectus abdominises, we have our what's called our linea alba, which literally just means white line. So albinism, white, linea, line, okay? In pregnancy, a lot of the time, this linea alba starts to separate to accommodate that growing uterus, okay? So sometimes you'll see that it stays separated even after pregnancy, and that can cause problems with like, I don't know, defecation and whatnot, okay? But your linea alba is going to be where those two rectus abdominis muscles join. It's that line that runs down the center of the two of them. Okay. Okay, let's do like 10 more seconds. Yeah, so external intercostals, okay? Remember that hoop skirt analogy, right? When you tie the rope to the bottom of that hoop skirt and you pull up, okay? It's going to pull your ribs up. So it's going to elevate your ribs, Next, we're going to do muscles of the shoulder and the arm. Okay. First, you have your deltoid. And if you remember, your deltoid is that like triangular shaped thing here. Okay. Your deltoid is going to be responsible for abducting, flexing, and rotating the arm. Okay. So pulling it away, pushes it forward, does a whole bunch of different things. Okay. For you guys, it's really important because it's a common site for IM injections. IM standing for intermuscular, or intramuscular, which means inside the muscle. Okay. Then you're going to have your pectoralis major. So your pectoralis muscles, important in pecs, right? They're going to be responsible for doing the climbing and the hugging motions. It's really important in post-surgery mobility, especially in something like mastectomies. Okay, so when you have that breast tissue removed. And then lastly, you have your serratus anterior. Okay, your serratus anterior, it's kind of hard to see from this diagram. It's going to be responsible for stabilizing your scapula. When you have a weak serratus anterior, it causes something called a wing, where like your scapula literally pulls away from your body and sticks out. So your serratus anterior. Okay. Okay. You can see your serratus anterior here. It like wraps on all your ribs and it's going to wrap around back to your scapula here. Okay. Let's see. I feel like sometimes the motion is helpful because it basically gets rid of everything that's not relevant. Okay. Okay, so your serratus anterior wraps from your ribs to the back of your shoulder blade here. Okay. It is considered an accessory breathing muscle. So, but really for you guys, it's more important when we talk about like those motions, that hugging motion. Okay. All right. So that's where we'll stop with lecture. I have 2 in-class activities for you guys. Okay. I have another crossword, and then once we're done with the crossword, I have a like riddle sheet for you guys to do. Okay, so I'm gonna split you into tables. For the crosswords, same thing as before. You sign up, you'll go to, this one is gonna be from chapter 6, the integumentary system. Yeah, it's shorter. And then the next thing is going to be an activity on Brightspace that you guys will fill out and submit as a group. Okay, so the crossword link is in there. Let me just set up the team thingies. Hold on. Okay. So you guys should be able to register for that. Oh, and I have to put you guys at your tables. That's right. All right. All right. So winning team this time is Kylie, Justine, Kia, and Pichaya. So I will write down your guys' names and candy will be provided when I see you in person in a week. Okay. So congratulations. Where's my little clappy hands? Okay. So the next thing I have for you guys, if you go to we're gonna go to evaluate assignments. Oh, let me do this as a student. Evaluate assignments. Mhm. I guess it's on page 2. Where is it? Okay, I guess this isn't on here. Hold on. Okay, so I'm gonna send you guys a quick email with the in-class activity. Okay, and you guys will complete that at your tables. You only need to submit one per table. Let me just communication content. Just make sure everybody's name is written on it. Okay. Okay. Where's my Brightspeed secrets? Okay. Hmm. Okay. So I just sent you a thing. Okay. So you should have it in your email. Work on that at your groups for the next like 15 minutes. Okay. Shouldn't take you 15 minutes. They're pretty quick. So yeah, complete those at your groups. Email one back to me. okay, with everybody's name on it. Like I said, if somebody's just not participating whatsoever, you don't have to put their name on it. They can be responsible for doing it on their own. And these are like graded as part of participation. So if it doesn't get submitted, then it's like a certain points deduction. Does that make sense? It's not like you're getting this put in your grade book. It's just part of your participation for today. So just make sure you email it back to me. I need to grab my little notebook so I can write down everybody's names, write down where we left off. But I still have my headphones. You guys should see it. Okay, guys, just like, I don't know, 3-minute warning. If you didn't finish, that's okay. Just submit it by tonight. Okay. But you guys have a couple more minutes to work at your tables if you want to work in groups. But yeah, I'm just giving you the heads up. I am going to end class at the 11:20 mark. So I see some people have started sending me the stuff, but just so you guys don't feel like I cut you off abruptly. Okay. So it is 11:20, so I'm gonna go ahead and end class. Like I said, you only need to submit one per group. So you guys know who's in your groups now, hopefully. If, like I said, if they weren't active in your group, like they never spoke or anything like that, that's on them to submit it on their own. So yeah. Otherwise, have a good rest of your night, guys. Or not night, sorry, day. And I will print out extra copies of chapter 10 and stick it in the classroom for you. And I'll put like a little like sticky note in front of it that says like 4 Professor Woodruff sections. Because I think a lot of you guys have like funds tomorrow. Maybe. I don't know. But all right. I will see you guys next week, or I'll see you on Thursday. Because it's Monday. So I will see you guys Thursday. Bye, everyone.